Hello everyone, my name is Anthony Harmon and I am your local professional real estate agent in Kansas City. This is going to be going over all the basics of the layout and components inside of an electrical cabinet. This video is going to be for a new homeowner and as someone who maybe even hasn't ever looked into an electrical panel before, doesn't know what it is, maybe is intimidated by it as they should be if they're brand new to it. So this is going to help you just get a very good understanding and groundwork of knowledge of what your electrical panel is, the components inside it, and a little bit of how it works. Quick disclaimer, I recommend anyone watching this video that is not experienced with electrical components or doesn't have any major electrical experience or background to have any of their work done by a licensed electrician, especially in your panel, because electricity is very dangerous and at the panel level it can be fatal. Here is the general layout of a home electrical panel. Now we are going to be looking at a standard electrical panel for a U.S. household. Your home electrical panel is going to be comprised of three main components: the enclosure, the breakers, and the bus bars. The purpose of the enclosure is to add a layer of protection from you and the electricity inside the panel. Bus bars are strips of copper that run down the center of the enclosure and tie directly to the two incoming feeder wires that supply the power from the power lines outside. They are made for breakers to connect directly onto for the transfer of power. There are also additional terminal strips on the side of the panels for the ground wiring and neutral wiring as well. The breakers are components that are made to attach directly to bus bars and isolate individual circuits of power in varying amperage and voltage configurations. In the United States, there are two standard voltage configurations of 120 or 240 volt. And these numbers are interchangeable, so if you see something that says 110 or 220, just know it's the same thing. There are many different varying sizes of amperage configurations that go along with these voltage ratings. Here you can see a set of feeder wires coming into the panel from the outside power lines outside your house. They either come from the lines on poles or they either come from under the ground. Each set of feeder wires are comprised of the same variations of wire. There's typically two lines holding a voltage load of 120 or 110 volts each. Those feeder wires come into the main breaker of your panel. The configuration of those wires is as follows. There's two lines holding a voltage load of roughly 120 volts each coming in to the main breaker. As you can see laid out, there's one line on top and then another line followed right into the terminal screws of that main breaker. Here you can see the ground wire coming in and hitting the ground terminal, which goes down to the terminal strip where you will connect the rest of the ground wiring for your circuits. Over to this side is the neutral wire that goes to the neutral terminal strips where you will attach the neutral wire for each of your circuits. Coming from the main breaker, electricity will flow down each of these bus bars. Each bus bar contains the voltage from the feeder wires coming in. The main breaker will control the voltage and amperage flow through the bus bars below. Standard home panels in the United States come in either a 200 amp or 100 amp configuration. You can tell this by looking at the amperage rating of the main breaker or by looking at the panel itself and seeing what it is rated for. Quick tip, if you're ever wanting to know how much amperage room you have left, so say you have a 200 amp breaker panel, and then you want to know how many amps you have left from how many breakers are currently installed, what you can do is you can go through each breaker with a piece of paper and write down the amperage label on the little switch on the breaker. Then you can go through all those, add up all those numbers, then take the amperage rating of your panel, the one that will be displayed on the main breaker or on the panel itself, either 100 or 200, and then you subtract that, the main breaker rating, so say it's 200 amps, you subtract that by the number that you got from adding up all the breakers currently in there. So say you had 120, you take 200 amps minus 120 amps that's currently in, and now you have 80 amps of room to work with. So you can still add breakers totaling up to 80 amps, and you'll have that much room left in your panel for adding in upgrades or new systems or anything like that. If you look at these larger breakers, they have two wires connected to them, and they take up two terminal spaces. These are 240 volt breakers, meaning they take up two breaker slots. So you attach a wire, one to each terminal screw, and each wire will hold the voltage of 120 volts, and then put together you get 240 volts. These are for your larger appliances like dryers or stoves. And if you look to the other side of the panel, you will see the smaller breakers that only have a single wire going to them, and only take up a single terminal space, 120 volt breakers. These are made up for most household applications. Majority of your panel will be comprised of these 120 volt single terminal breakers. Just to give some context for very beginners, since I've been going over and I've been using the terms voltage and amperage a lot, this is not a comprehensive breakdown. This is just to give you some footing so you know whenever I use them, they are different things. So think of electricity like water. It's not an exact representation, but it's close enough to get a basic understanding. Voltage is the intensity of the stream of power through the line, like water pressure through a pipe. And amperage is the volume of power coming through the wire, which is largely dictated by the size of said wire, like the volume water through a pipe. You may be able to put tremendous amounts of pressure through a small pipe, but you won't get the same volume out of said pipe unless it is a certain size. So in short, the larger the wire, the more capacity for amperage. So these are all of the basic core components to your home's electrical panel and some of the purposes behind them. I did not go into too much detail because this is a very beginner video made for someone just being introduced to home electricity. Maybe it's your first home and you've never had to deal with anything like this because you've rented or whatever the case may be. This was just a basic overview to give you a good idea of terms of electricity. So whenever you're talking maybe with your electrician or you're thinking about doing some basic install stuff, you understand the terms that we went over briefly, and then also the components list so you're not completely blind whenever you're staring at your electrical panel in your home. However, if you would like to see more in-depth videos, like the breakdown behind the concepts that we touched on, like voltage and amperage, neutral and ground lines, what it means to have a single-phase circuit or a three-phase circuit, or more in-depth tutorials like how to install a breaker into your home panel, comment below and I would be more than happy to teach you guys even more. As always, be safe, be smart. Thank you guys for watching, and I will see you next time.